Thank you for bringing this to us. Okay, so this is 4.2. We're going to talk about how to solve compound inequalities. So here's one example of one compound inequality. So this two inequality joined by n, it is one compound inequality. When you have two or more inequality joined by n or all, that is called one compound inequality. So in this example, x has to be greater than or equal to 2 and also has to be less than or equal to 5. So the first one, that's the first graph, the first inequality, x is greater than or equal to 2. So that will, we locate 2 and we can shade the right side of 2. Okay, x is greater than or equal to 2. The second inequality, x is less than or equal to 5. So we locate 5 over here. And then we're going to shade the left side of 5, including 5. Because the equal side over here, then the 5 is included. When this n is included, we use bracket instead of the parenthesis. Okay, so bracket over here. Now, this compound inequality says that x has to be greater or equal to 2 and also less than or equal to 5. So what are those numbers greater or equal to 2 and also less than or equal to 5? Where are those numbers? Can someone tell me? Yeah, you guys muted. You guys can unmute yourself by pressing the space bar. Are you guys there?
2 and 5?
2 and 5. Between 2 and 5. Okay. So greater than or equal to 2, less than or equal to 5. So it will be between 2 and 5. So greater than or equal to 2, so it will be on the right side of 2, but also has to be less than or equal to 5. So that will be on the left side of 5. So only those numbers that are between 2 and 5, also including 2 and also 5, that satisfy this compound inequality, okay? Because this is n, so both of them had to be satisfied. So both of them had to be true. So greater than or equal to 2, also less than or equal to 5. So only this part here that satisfy both of them. So if you're looking at the graph, you see that the solution will be the part that is the intersection, which is the double shaded part over here. So the blue one and also the orange one, and they double shaded over here, right? And that's the intersection of these two. So the solution set will be from 2 to 5. Okay, let's put that in interval notation. So it will be the interval from 2 to 5, bracket here, including 2, and also including 5 over here, bracket over here, okay? So remember, when you have n, then both of them have to be true, okay? So you look at the intersection of the two sets right here. Okay, now let me talk about what's the intersection. Let me talk more about intersection and union, okay? So you have this set A and this set B. When you union them together, okay, so union means put together, right? Okay, so you will get the whole A and also whole B. So it's everything in A and everything in B. So the yellow shaded part here is the union of A and B. The symbol for a union is like a U, okay? It's a U like that. This stands for union. So you read this as A union B. So that is A and B put together. So the yellow highlighted set over here. Intersection is the part that they cross each other. So A intersect with B will be this part right here. That's the intersection. Now intersection kind of like opposite with union. So you change this union sign here upside down. So like an upside down U. So that's a symbol for intersection right here. So that corresponds to this part right here, okay? So this part over here is the intersection of this blue one and the orange one. That's the solution set for this compound inequality when in between the inequalities are joined by n, okay? Okay, So that's the intersection right there, okay? So the intersection is the solution set when two inequalities are joined by n. Now, some people find that a little bit hard to understand when they say n, how come you take the intersection? You don't take union, right? Now, let's think about some example over here. Say we are looking for people who are smart, okay, and beautiful, handsome, and kind, okay? So we have some people who are smart, right? Okay. And we have some people who are beautiful and we have some people who are beautiful and handsome, okay? And we also have some people who are kind, okay? So where are those people who are smart, beautiful, handsome, and kind? Where in this diagram, in this Venn diagram?
In the middle.
In the middle, right here, right? The intersection right here, okay? So it's right here, okay? That's the intersection, okay? So only a small part, right? Okay. It's not an empty set, definitely, okay? So that's the intersection. The reason for that here is you keep on putting more and more condition on it, right? Has to be this, has to be this, and also has to be this, okay? The more I put in, the smaller the set. Only the intersection will satisfy all of this condition. So that's why you take intersection. So when you have inequality joined by n, the more you put over here, okay, then you're more strict with it, right? So it has to be this, and has to be this, and has to be this. So more and more you ask to satisfy, then the smaller the set, okay? So that's why only the intersection will satisfy all those conditions. So when inequality are joined by n, then you will take the intersection of the solution, the set, okay? So you take the intersection of the set, only the intersection will satisfy all those conditions. Now, let's look at this one right here. This is one compound inequality. We're trying to solve this compound inequality. Then we will solve each one of them separately first. Okay, to solve the first one, what do? You can get rid of the denominator by multiply both sides by 2, right? So multiply both sides by 2. Multiply both sides by 2, does it change this inequality sign? Does it switch? Yes or no? When you times positive number, does it switch this inequality sign?
Probably no.
No, okay. Multiply by positive quantity, the inequality sign is not going to switch, right? Think about a scale is not balanced, right? One side is heavier, okay? The other side is lighter. And if you double this side and double the other side, the heavier side is still heavier, right? Okay. So when you multiply both sides by positive quantity, inequality sign is not going to switch. And when do you switch inequality sign? Do you guys remember? One of the time that you switch inequality sign is when you multiply both sides by the same negative quantity. Okay, times negative. So for example, if you times -2 over here, on left side, right side, then you switch. But when you times +2 on both sides, inequality sign is not going to be switched. Okay. So inequality sign stay the same. Now you simplify this side here, you distribute, then this side, what do you get? X plus 2, right? And the other side 0. Subtract 2 on both sides, x is greater than -2. Okay, now we solve the first one. The second one here. This one we add 3 to both sides.
X is equals to 4.
And then divide both sides by 2. X is less than 4, right? Okay. Now, now this two inequality joined by n, what should I do with this set? We take the union or intersection of the two. Oh, okay, let's get to that later, okay? Okay, x is greater than -2. I'm gonna shade, okay, so I find -2 over here. I'm gonna shade the right side of -2. So notice I use parentheses here because there's no equal sign here. x couldn't be equal -2, so I use parentheses, okay? Now here x is less than 4, so I locate 4, and I will shade the left side of 4, so it will be like this. Now, where is the solution set? Well, because this is n, so the x has to satisfy this, n has to satisfy this. So should be the union of the blue one and the green one, or the intersection of the two? Which one?
The blue and green.
The intersection of it, right? So because it and here, you have to satisfy both of them. So you take the intersection. So will be this part right here. That's the intersection of the blue and green. So the graph of the solution set will be here, from here to here. Okay, that's the graph. Now to write the solution set in internotation, what should I put over here?
X is then equal to 2, but less than.
You got it, okay? So a parenthesis -2, 4, and then parenthesis. So that stands for this interval right here, right? Okay, good. Okay, if I write this in set builder notation, then I will have this this set notation. This pair of curly braces is a set notation. And then the variable here is the x, okay? But not all x. So you put a bar here for, and then you put the inequality right here. So x is actually between -2 and 4, okay? So you think about this x. X is between this -2 and 4. So we put down x is greater than -2 and less than 4. X is between -2 and 4. Okay, so this is a set builder notation for the solution set. This is the interval notation for the solution set. They mean the same thing. Okay, question? Okay, let's try the next one, number 2. This time we have 2. Okay, I will let you try that for a minute. Okay, tell me what will be the solution set. Go ahead and try. I'm gonna stop my video for a while. Okay, I'll give you 2 minutes to try. Did you guys get it? What do you have?
I got x is greater, or sorry, x is less than 4, but greater than -4.
Okay, let's go over this. Okay, let's do it. So the first one here, you add 1 to both sides. So x is greater than 4, right? And then the next one over here, you will divide both sides by -2, right? When you divide both sides by the same negative quantity, what happened to this inequality side here? Switch or not?
It switches.
It switches, right? Okay, so it's going to switch. So inequality side will point the other way. So the tip will point to the left instead of pointing to the right, okay? So divide by -2 over here on the left side, you get x.
X is less than -4.
And then this is -4. Yes, very good. Okay, now this is not the final answer over here. Okay, you just solve each one separately. This is one compound inequality, so you have to combine them. So this 2 inequality joined by n, so both of them had to be satisfied. So you would take the intersection. Okay, so compound inequality, when they join by n over here, then you will take intersection. So I will graph both of them greater than 4. Okay, so greater than 4 will be this one over here. Less than -4 will be this part over here. Well, do they intersect?
No.
No intersection. So what do you think about the solution set if there's no intersection?
None.
None. It's an empty set. You got it. Okay. So the solution set will be the empty set. The symbol for empty set is a 0 with a slash, remember? Okay. So we can just put down this symbol. The solution set is the empty set. This is the empty set. Well, since it's an empty set, there's nothing to graph. So you don't need to graph it. Okay. There's nothing to graph. Okay. Okay, you guys got it? Okay. So sometimes it happened that the solution set for a compound inequality could be an empty set like this, okay? So nothing to graph. Okay. Next one, we want to go over double inequality. This is one example of one double inequality. So it had this inequality sign and inequality sign over here, okay? And the way that we read this is, we start with the x, okay? So we read this as x is greater than or equal to 2 and less than 5, okay? It is n actually in between. Both of them has to be true. X is greater or equal to 2 and has to be less than 5, okay? Okay, to solve this type of double inequality, notice the double inequality usually we want to write it in a way from small to big. This is the smallest, this is in the middle, that's the biggest, okay? Okay, so this is one double inequality. How do we solve it? To solve this, okay, we will, just like solve an equation, we will try to isolate this x. So we subtract 5 on all sides. And now we got -8. Well, when you're subtracting or adding, inequality sign is not going to switch. Now you got this. What's the next? So notice that whatever operation you perform, you have to perform to all sides, okay? Perform that on all sides. Now, after that, what do you do to isolate this x?
Divide all sides by 2.
Yeah, divide all sides by 2. Divide by positive 2 is not going to switch inequality sign because you're dividing by positive quantity. So no switching inequality sign, okay? So we keep the same. The inequality sign will stay the same. Now this will be -4. This is x and this is 1. Now the way that you read this is x is greater than or equal to -4 and less than 1. To graph this, we will shade this from -4 to 1. Now, this one has an equal sign, so we use bracket over here. This one has no equal sign, which means 1 is not included, so I use a parenthesis over here. So the internotation for the solution set will be what? Bracket -4,
1,
comma 1, parenthesis. Okay, good. Okay, what about separate notation? The set of all x such that, what should I put over here?
what we solve, negative
Yes.
1 is less than or equal to x and less than 1.
You got it. Okay. Yeah. You put the same inequality here, the one you just got, put it over here. This is a condition for this x to be in the solution set. Okay, good. All right. Now I want you guys to try this number 2. Okay, give yourself a couple minutes, okay, to do this and tell me what you get. Okay, I'm going to stop the video and then also I'll come back to you. You guys got it?
I got -3 is greater than or equal to x, which is less than but equal to -4.
Okay, let's go over this, okay?
Wait, did you say less than and equal to or greater than and equal to?
It should be greater or equal to -4. Let's go over the detail, okay? Let's go over this together. Okay, so first we want to get rid of this -7, so add 7 to all sides. So we get 9, less than or equal to -3x, less than or equal to 12. And then we divide all sides by -3. So when you put down divide by -3 on all sides, you have to switch inequality sign right at this step because that's the action step you're dividing. So you have to erase the inequality sign, and switch it, okay? So now the tip of this inequality sign is going to switch, okay? So the tip will point the other way, okay? Now, once you have done this, okay, you have to switch it right at this step that you divide by negative quantity, okay? Now, after that, this will be -3, and then greater than or equal to, this is x, greater than or equal to, and this is -4. Now, as you can see here, over here, -4 is actually the smallest one. in here, okay? The tip point to this, the tip. Okay, this is greater than equal to this is greater than equal to this. So this is the smallest. So we prefer to write the answer from small to big. So let's put that in the order from small to big, okay? So we have -4 first, and then x in the middle, and then -3 here. You see, as long as you keep the tip of this inequality side point to the same quantity, it will be equivalent. So x is greater than or equal to -4 is the same as -4 less than or equal to x. You see, the mouth open to x, so the mouth here open to x, right? So these two are equivalent, okay? And then this one here, you will have, so these two are the same inequality, double inequality. So these two are the same double inequality, but we prefer to put it this way, from small to big. So smallest, the middle one, and then the biggest one right here, okay? So the way we read this, we will start with x. You read this as x is greater than or equal to -4 and less than or equal to -3. Do you guys get it? Do you understand now? So the part here is remember to switch this inequality sign right here. Okay, don't forget to switch it. Now, so don't forget, okay. Now some of you might say, what happens if I put it this way? Okay, so now some people had these things here. Say we had this. Is it possible? Say I have something over here. Do you think this is possible? Can you put something like this? What do you think?
No.
It's not possible because the translation, x is greater than or equal to -3 and less than or equal to -4. This actually implies that -4 is greater than or equal to -3, which is not true. Because you see on the number 9 right here, -4 is over here, -3 is over here. -4 is smaller than -3. You cannot have -4 greater than or equal to -3. So this is wrong, okay? So you cannot have something like this. Okay, so the graph of this is going to be like this, okay? So bracket -4 and then all the way to -3. The equal sign here means these two ends are included, right? Okay. So to put the solution set into rotation, so that will be bracket -4 comma -3 bracket. So to put the solution set in set-builder rotation, so we have the set of all x such that, what should I put over here?
The -4 is less than or equal to x, and x is less than or equal to -3.
Yes, you got it. Okay. Except it is a convention that we usually like to read, start from x. So you read this as x is greater than or equal to -4 and less than or equal to -3. Okay, good. All right, now the next one here. This is a compound inequality containing the word or.
If
okay?
I may interrupt for a moment.
Go ahead.
So parentheses and square brackets, just to make sure, because I always have to reread this or Google it. But the parentheses, right? They are open, so it includes the number. Like if we were to take -4 and -3, it would include -4 and -3, right?
Yeah. So over here,
brackets do not include -4 and -3, but it would be like -4.1 through -3.1.
Okay. So when you have bracket over here, it's the same as you include the endpoint. So it's like you have a solid that one over here. Okay. So we include the two ends.
Okay. So it would include -4 and -3.
Yes, the -4 and -3 are included. If you have parentheses, then that means the two ends are not included. So you could have here, you can have like -3.99, etc. You can have -3.999, etc. Okay. And then over here, you can have -3.001, etc. Okay. You can have -3.00001. As long as it's on this side. You can get very close to it, but just not including -3. So parenthesis means the endpoint are not included. Bracket means the endpoint are included.
Okay, got it.
Okay, good.
Thank you.
Right. So let's get back to this one. Now the compound inequality containing the word or, okay? So this is one compound inequality. The two inequalities here are joined by or. So x is greater than 0 will be this blue part right here. X is less than -2 will be this orange part right here. Now, because this is or, that means you just need one of them to be true. Say, for example, if you go to a park, right? We say if you're a senior citizen or you're under 12-year-old, you pay this price, right? So you just need one of them to be true, okay? So therefore, both of them will satisfy. So if you're on here, then it's okay. If you're here, that's okay. So both of them are okay, okay? So the solution set will be the union of the two sets, okay? So in this case, it will be this union this. Now remember the union symbol, right? So we have this set, the orange one is from -infinity to -2. And then the blue one here is from 0 to infinity. And then you union them. So the union side is this kind of like a U right here. So you union them together, okay? So you put them together by union. Notice that they don't connect together, right? And then you union them. So you union them like this, okay? Now think about in real life example, okay? So if you go to someone's house and then they ask you, would you like water or juice? Okay, and then, okay, so they will ask you, what would you like to drink? They say, oh yeah, water or juice will be okay. So if they give you water, you take it, right? If they give you juice, you also take it because it's an or. So as long as it satisfies one of them, you take it, right? So it's the union of the two sets, okay? So when you have, so let's summarize and compare the compound inequality that joined by n and joined by or. So when you have inequality joined by n, you take union or intersection of the two sets. Which one? Union or intersection? If it's n.
Intersection.
Intersection. You got it, okay? When two inequality joined by or, you take the union or intersection of these two sets.
Union.
Union, you got it. Okay. Okay, now let's try to solve this compound inequality. I used to put one compound inequality like this on the exam. I say, solve this or this, and the student just pick the easy one to solve, okay? But remember, this is a compound inequality, which means you solve both of them and you take the union of the two sets, okay? Remember to solve both of them. Okay, now solve the first one here. So we'll multiply both sides by 3. Then we get x over here. This side here will be 2. Times positive quantity on both sides. Inequality side is going to remain the same. Okay, now what about this? We'll divide both sides by -1 or multiply both sides by -1. Do we need to switch the inequality side? Switch or not? Yes, yeah, we switch. So point the other way, the tip. Now, and then we add 2 to both sides. So we have x is less than -1. Now let's graph it. So x is less than -1. So locate -1, you shade the left side. X is greater than 2. Locate 2 and shade the right side of 2. Okay, so because the two inequality are joined by or, you take the union of the two sets. So it will be this one together with this one. Okay, so that's a graph. Now, how do you write the solution set in interval notation? What should I write over here? What should I write over here?
Infinity per comma -1 union parenthesis 2 comma infinity and parenthesis.
Good job. Okay, thank you. So this part here is negative infinity, parenthesis, negative infinity, comma, -1, parenthesis. This part here is parenthesis 2 infinity, and you union them together. Okay, so union. Okay, good job. Okay, now the last page over here. This one for you to try. Okay, so go ahead and try. Okay, since we kind of running out of time, let's do it together. So to do this one, we will solve both of them, and then later on, because this is OR, we'll take the union of the two sets, right? So let's solve each one first. So over here, we subtract 3 on both sides. This one here, we will multiply or divide both sides by -1. We divide both sides by -1, then we'll have x over here, and 0 divided by -1 will be still 0, right? Okay. Okay, let me write it down first now. So when we divide both sides by -1, inequality side here will switch. So the tip will point the other way. 0 divided by -1 is 0. So x is greater than 0. Now let's graph both this one and this one. X is greater than or equal to -6. So locate -6. You shape this side right here. And then x is greater than 0. So locate 0. And then I'm going to shape the right side of 0. Okay. Now, because these two inequalities are joined by OR, then you only need one of them to be true. So we take union. So we take the union of them. What's the union of the green and the blue part?
Bracket -6, comma, infinity, bracket, union, parenthesis, 0, comma, infinity, parenthesis.
Okay. Technically, it is right. However, you can actually simplify that, okay? So if you union them together, okay, when you union the green and the blue is already a part of the green, right? So think about this. You see the green is here and the blue is a small part inside. When you put them together, the green part already covers this part right here, right? So when you union them together, you just get the green part right here. So you don't need to put down union 0 to infinity. Okay, so basically the union will be from here all the way to infinity. Okay, so that's the union of the two sets. Okay, so we just need to put down bracket. So we just need to put down bracket -6 to infinity. This already includes the blue part, okay? But this is a small part inside it. So we don't need to mention this, just this the big part right here. So that part will cover this already. So that's the solution set, okay? To write that in separator notation will be the set of all x such that x is greater than or equal to -6. You got it? Question? Change color right here. Okay. Okay. Now the last one here. Oh, let's go over this together. Okay. X is greater than or equal to 2. Okay. So I will locate -2. Greater equal -2 to be the right side of that. Okay. And then x is less than 0. Okay. Let's use the blue color right here. Less than 0. So 0 right here. And parenthesis. So to be on the left side of 0. Okay, left side of 0 right here. Now, because this is OR, you take union or intersection?
Union.
Union. Yeah, you take the union of that, right? Okay. So what happens when you union the green part and the blue part right here? What do you get?
It's between -2 and 0.
Union. You put them together. You put the green part and we're not talking about intersection. We're talking about the union. So if you put this green part right here together with this blue part over here, what number do you cover? So it covers every number over here, also cover every number over here. So it is going to cover every number on the number 9, right? Do you see?
Infinity, comma, infinity.
Yeah. So you see the graph? Okay. So it covers every number over here, also every number here. Basically, it covers every number on the number 9. So it will be everything. Okay. So the union is actually, the union of this green and the blue right here will be everything on the number 9. So the graph will be this whole thing on the number 9 right here. Okay, you will shade every part. So this whole number 9 will be shaded. Okay, so the solution set, to why the solution set over here. So you see the difference between this one and this one. This one over here, they when you union, this is a part. This part here is part of this. So when you add this to this, you're not adding something extra. You still get the green part right here because this is a small part of this green. So you get this. Now what happened to this? These two overlap. So if we put the green and the blue part together, you get the green part right here together with this blue part right here. And you get everything on this number 9. So everything on the number 9 here will be inside the solution set. Okay. Now the solution set here will be everything on the real number 9. So the solution set here will be all real number. So using this set notation, this stands for all real numbers. And then to put that in interval notation, you can put down parentheses negative infinity to infinity, right? So negative infinity, well, and then to infinity, and we can never reach negative infinity or infinity. You always use parentheses before or after infinity or negative infinity. Okay.
Would you exclude 0 though, because it's not equal to 0?
But okay, the 0 here is included. Why? Because the 0 here is inside the green. Remember, this is an all, right? So the 0 here is actually greater than or equal to -2. So the 0 here is inside this green part here. So 0 is included. Also -2 is included because that is inside the blue one. You see what happened over here? So the 0, x is greater than or equal to -2. So you have all this number over here. You can have -2, -1, negative 1/2. You can have 0. You can have everything. Everything here, right? Will be included, the green. So 0 is included because 0 is greater than -2. 0 satisfies this inequality. Okay? And then after you have all of this, and then you put down the blue part right here, then everything over here will be included. So you have everything here and everything here, then you get everything on the number 9 right here. Let me try to think about this. Okay, let me try to draw the diagram. So you have this part right here. Okay, so say this is the whole. This is the whole thing, right? And then you have the green part right here. You have, say, this part right here, the green part right here, right? And then you have the blue part right here. Now, when you put this green and the blue together, you union them. Do you get this whole thing right here? Is this the whole thing? Right? Because they overlap. You see, they overlap over here. If you have the green and the blue together, you get the whole thing. That's the union. Union means you put together. Okay. Any other question? Now I'm going to stop share. Okay. Let's see, are you guys still here?
What do you do?